Hello, everybody. Hello, Trig students. I hope you're doing all right. Just wanted to let you know that I really do miss you all, and I hope that you all are doing well. I hope you're practicing social distancing and doing the things that you need to do. We all need to do those things. I'll say this: I'm staying away from all my family members right now. I'm basically home alone, and it's tough being alone. And I'm an introverted person to some extent. Although I really do like social interaction too. But um, I'm a person that doesn't mind to be by himself sometimes. But it's been tough. But you're going to have to hang in there. I know some of you are working though, and you're forced to go out. And I just hope and pray that you all stay safe and don't catch this virus, and that it doesn't cause. And you're not invincible because there are people that are really getting sick that are even younger people. So please be careful. Do your part. I hope, just hope that your family doesn't get sick and none of your loved ones get sick. Um, I want to make a video today to talk a little bit about phase shifting. And this is going to require us to talk a little bit about some things. And I want to first start with two functions. I'm going to write them out on paper and then put them up on the screen here. I'm going to start with these two functions right here. Y equals x squared plus 1 and y equals x plus 1 in parentheses squared. Okay. I'm going to I'm actually going to do this one a little bit different. I've not pulled up this website before. I'm going to try this, see if it works. We're going to pull up if I can, and I apologize. I'm so used to using the Chromebook. I'm using my personal laptop now, and it's a little different. So I'm going to pull up a website here for Desmos, and we're going to start graphing. So I'm going to go to the graphing calculator. This is a great graphing calculator app. You can use this. It'll help you. I won't say that it'll necessarily help you with these widgets that are on the Khan Academy. I'm going to tell you right now, they require a lot of patience. But I understand that I understand that they're a little bit difficult. I understand digital instruction's hard. Like I said, I hope, if nothing else, I hope that you all have learned that online classes are tough. They take a lot of responsibility. So when you go to college, be mindful of that when you sign up for an online class, that you have to put a lot of responsibility because you're not physically there. It almost makes it feel like you don't have to do anything or that you forget it. You put it on the back burner. That's not what you have to do, obviously. Some of you have probably figured that out. My internet may not want to cooperate with me here, so I'm not sure if it's going to work, but we're going to try this. Okay, so that's not going to work. All right, so let's do it this way. I'm going to use my calculator and I'll show you the screen. So I'm going to graph these, and I'm using my fancy one that graphs in two different colors. Some of you, I think, have some of you have, there's a couple of you I know that have one like this, but I'm going to graph those two functions. So the blue function is is that first one, y equals x squared plus 1. Okay, let me get it where you can see it. The blue function is y equals x squared plus 1. The red function is y equals parentheses x plus 1 close parentheses squared. So see, there's a different kind of transformation there. And you might remember you did a little activity in Algebra 2, and I know you did it because I used to do it when I taught Algebra 2. And not that I didn't invent it, I didn't create it. I don't really know where it came from, but I do know that Miss Oliver shared it with me, and I used it. I didn't use it exactly the same way she used it, but we used it. But you did an activity, anyways, where you used coloring pencils and you drew different. You took parent functions and you transformed them in different ways, and a couple of the transformations were similar to those. So plus 1 on the outside, we go back to our two functions here. The top function, plus 1 on the outside, not being squared, that shifts the whole graph up 1, okay? And the bottom one shifted it left 1. We'll go back to our calculator screen here. and you can see that it shifted it. The blue one shifted it up one, and the red one shifted it right one. Because normally the parent quadratic function U-shaped graph set right there at 0, 0. So the plus one on the outside shifted that whole graph up one. The plus one on the inside shifted it to the left one. Sorry, I have to go my right, your left. Shifted it to the left one. Okay? And if it had been a minus one inside parentheses, it would have shifted to the right one. So on the outside, plus shifts it up, minus shifts it down. On the inside, plus shifts it left, and minus will shift it right. That's a little bit different than what you're probably used to, or what you would have thought it would have been. There's reasons for that, and if I could go into more of a visual with you all, I would, and I'd show you that. But anyways, what we're going to do, we're going to look at this function here on the Khan Academy. So the widget is a little bit hard to work with sometimes. It takes a lot of patience. You have to play around with it and figure it out. So this is a cosine function. So we're going to shift the points. We can shift everything left. We can shift this left and right. We can shift this up and down and left and right, and we can shift both of these points around. So we've got a point at a maximum. We got a point at a midline. Okay. So let's look at our function. I think it's easiest to take care of the vertical shift first. So plus 2, we're going to shift this whole graph up 2. Now, obviously, this needs to be shifted up or down 2 as well. So now, cosine shifts. Cosine is going to not start. Cosine doesn't start on the midline, though. Okay, sine starts on the midline. But for your starting point, cosine actually starts at a minimum or a maximum. And that depends on whether the A is positive or negative. A is positive, so it's going to start at a maximum. Now, the amplitude is A. That's the 5 right there. Okay, if you looked at my PowerPoint from yesterday, you would know what amplitude is. I think everybody knows what amplitude is that's done their assignments. We even talked about amplitude and period before the ACT. We actually did that in person a little bit. So this has gone up 5 and down 5 from the midline. The midline's 2, so it's going to go up 5 and down 5 from 2. So I need to move some stuff around, and like I said, I'm having a little technical problems here. So I need to move some stuff around. I need to make it to where the maximum occurs right there. So it's going to go up 5 from 2. So it's going to occur at 7. And it's going to go down 5 from 2. So the minimum should go down 5 from 2 would be negative 3. That's where I've got it set right now. Okay. So we're looking at the function going between negative 3 and a positive 7. Okay. All right. Now we got to take into account the period, and we got to take into account the phase shift. The easiest way to do that on the inside of that function right there, the easiest way to figure out your period, you need to take and find the b value. It'll be tempting to say just say the b value is 2 and go with it. And that'll be fine for the period because the b value is 2. Okay? It is 2. But I'm going to tell you right now, what I don't like about this website, and it doesn't have this example, but we'll go to the next. When we go to the next example, unless it's a graph, unless it gives me 2 graphs in a row. But if it gives me the equation problem, I'm going to try to do one of those 2 with you. But if it gives me one of the equation problems where you're figuring out, or whether you're given some information, you have to write the equation. What I don't like about this website is it doesn't leave the b factored out. You'll notice from yesterday that my anatomy of a trig function had this. Let me write it out. So that's what you can see that. Everybody can see that in there, hopefully. That's the anatomy of a trig function. That is where A is your amplitude. B is used to find the period. Remember, the period is 2 pi divided by B. Do not forget that. It's not, the period is not B. It is 2 pi divided by B. I made a silly mistake a while ago, and this is probably my 5th attempt to make a video, but I made a silly mistake on one of them because I forgot that. So do not forget that. Okay, we're all prone to mistakes once in a while. The minus C is the phase shift. That's part of the phase shift, the C. And the D value shifts it up and down. That's the vertical shift. That's what we did. That's what you were working on with the first assignment. And I made a video yesterday about that. So with that, we want to take and we want to shift this around a little bit. So we got to figure out how this is the period. So when I take that stuff on the inside, the 2x minus 3 pi, I need to factor the 2 out. Okay, I need to factor 2 out of that. So I got to figure out what's left in here. What's going to be left inside of this for that to work? Okay, so I'm going to figure that out. I'm going to take x minus something. Okay, I know it's got to be minus something. What do I multiply 2 by to get 3 pi? Well, the easiest thing to do is to take 3 pi and divide it by 2. Because if I turn around and divide by 2 and then I multiply by 2, you don't change anything. Okay, because those are opposite operations. And you can see if you distribute that 2 into there, you get 2 times x, which is 2x. And 2 times 3 pi over 2 would be 6 pi over 2, which is 3 pi. Okay? So we're going to use that to help us determine the period and the phase shift. So 2 pi, so b is 2. So 2 pi divided by b is the period. I'm actually using a mechanical pencil. So 2 pi divided by b, which is 2. So that comes out to be pi. And I'm not using it very well. But that will simplify 2 pi. Okay? 2 pi over b is your period. 2 pi divided by 2 gives me pi. So the period is pi. So from basically what that's telling me is that this function will repeat itself in pi distance. So I'm going to have to figure out how to maneuver this. So I want it to, if I'm thinking about this, okay, so let's put it back right there for just a minute because we've not phase shifted just yet. We want to start right there. We've not moved it side to side any just yet. So the distance, so this thing has been moved. So the distance, okay, so period's going to give me the distance. The easiest way to determine that is the distance between your maximums to maximum. One maximum to the next maximum. One high point to the next high point. One top of the hill to the next top of the hill. If you want to think about it like that. So I need that distance to be pi. Obviously right now it's not, because obviously right now it's like 4 pi. If you look at it the way it is. Okay. So we're also going to be phase shifting this thing. And let's go ahead and take care of, let's actually do the phase shift just like we did the vertical shift first before we did the amplitude. We really need to do, and it looks like I need to download some sort of whatever. Go away for now. All right, nobody likes you. All right, so I need to look at, just like we took care of vertical shift first, we need to take care of phase shift before. We did vertical shift before amplitude. We need to do phase shift before period, really. So once I factor that 2 out, now I can see on this that it's a minus 3 pi over 2. That means I'm going to go to the right 3 pi over 2. So this point needs to be shifted to the right 3 pi over 2. That's a pi and a half. Okay. Now we can move this one accordingly. So we've shifted everything to the right 3 pi over 2. Now I need my period to be pi. Now the distance between your maximum to maximum is that distance. But of course, we have to think about it. The distance between a maximum down to a minimum needs to be half of that. So that would need to be pi over 2. So I need to have this function is going to be kind of tight, but I'm going to need this function to be, I'm going to need this value right here to be a fourth of that distance. I need the distance between a maximum to the next maximum to be pi. So from 3 pi over 2 to this value, which would be pi over 2, that distance is pi. You also can think about it in terms of the minimums too, for that matter. Minimum to minimum needs to be pi. Well, the distance between pi and 2 pi is pi. So you have to kind of move this left and right and play around with it until you get it set. So once you got that set, you got your amplitude, which is 5. Vertical shift's 2, so everything's been moved up 2. So here's the midline. So I'm going to go down 5 to -3. I'm going to go up 5 to 7. Check, check. Got that done. Make sure that you've shifted everything. The starting point, cosine, remember, starts above the midline or below the midline. Starts at your maximum or starts at your minimum, depending on what A is. A is positive, so it's starting at the maximum. Shift that baby to the right 3 pi over 2. And then you're going to shift this point left and right until you get it to where the distance between your maximums is your period, or the distance between the minimums is the period, which is pi in this case. Once you have all that, you can check the answer yes, and you can go to the next question. Now, here's the other one I wanted to talk about. So this one is one of these where it gives you the function. Notice that B is not factored out like I like it. Okay, notice that. Be careful of that. All right, so it's giving you a maximum and it's giving you a minimum. So right now we can tell that the amplitude is half of that difference right there. Okay, the amplitude's your distance from your midline up to your maximum or down to your minimum. I made a video about that last week. So half of this distance, and amplitude's a y. Okay, so let's just find the amplitude first. We notice it's a cosine function. We're going to find the amplitude first because that's the first thing right here in our equation. So the amplitude is going to be half of that difference right there. So in terms of the y's, well, in terms of y, this goes from -9 up to -3. Okay, -9 up to -3. So with that distance right there, if you counted it from -9, it's 1, 2, 3, 4, 5, 6. 6 total distance right there. So halfway in between there would be -6. So this thing's been shifted. This thing has an amplitude of so the amplitude is going to be half of that difference. I'm sorry, half of the distance right there. So the distance is 6 between the minimum and the maximum, right? From -9 to -3. So half of that's going to be 3. So the amplitude is 3. Cosine function. It's really hard not to talk about the vertical shift at the same time here. We know this graph has been shifted. The midline, remember the default midline is y equals 0. I made a video about that yesterday. So vertical shift, this has been shifted down because now the midline is at -6 because that's what's halfway between -9 and -3. So I'm going to put a -6 for my vertical shift. I'm just going to go ahead and do that, have that out there. We've taken care of that. All right, so that takes care of everything in terms of y. Now we got to talk about x. X can be tougher sometimes with this, honestly. So we need to figure out, even though they do not have on this, they do not have the b factored out, you can put it in factored out, and the program will accept that answer because I did it earlier. Just got to make sure you do not forget what is the period. The period is 2 pi divided by b. Okay? All right, so we're going to go to this question. We're going to figure out what the period is. So the period from the graph, the period would be the distance between a maximum to a maximum, or from a minimum to a minimum. So this difference right here, it goes from -3 to -2. So my period is 1. Okay? All right, this is the part where I messed it up earlier on the one I was doing. That means that 2 pi divided by b, which is the period, right, is going to equal 1. 2 pi over b equals 1. So I need to figure out what b is equal to. Well, normally what I would do is I'd multiply both sides by b, and I'd solve this down for b. And I might have to do a couple steps to get there. Okay? But it's pretty obvious here, even when you do multiply both sides by b, and it might actually be obvious regardless, you might not even have to really do this, but if you multiply both sides by b, I get 2 pi equals b, because the b's will cancel out there, and I'll get 2 pi equals 1 times b, which is just b. So b is equal to 2 pi. So I'm going to put that in there. That's the next thing to put in here. I'm going to put 2, and you can type pi for pi, and it'll transform it to pi for you. Now we're going to put parentheses and we're going to put X, X, and now we're ready to look at phase shifting. So how much has this been shifted? So the maximum normally, okay, this is a cosine function, so cosine starts above or below the midline. I almost wished it would give me a sine function. Remember, sine starts on the midline, okay? So you would want to take wherever this point is right here, that's going through the midline at -6, you want to figure out if it was a sine function, you want to figure out how far did it shift it, left or right. Obviously, this one's been shifted left, okay? But because this is cosine, you have to look at the maximum. How far has the maximum been shifted? Normally, for cosine maximum is at the default maximum would have been at the x value of 0, okay? But this has been shifted left 2. Okay, it's been shifted to the left 2. Instead of it being there, we've shifted it left 2. We've done other things too. We've shifted it down, all kinds of things. But this has been shifted to the left 2. Okay, because it would have been at 0, but now it's been shifted to the left 2. So we're going to put a -2 right there. And we're going to hope this works, but it may not. And I foresee one little issue maybe with it, why it won't work. Oh, it's going to work. So that gives you an idea of how to do this. I hope this video has been helpful. I know this is difficult. Once we throw in amplitude, period, vertical shift, and phase shifting all in one problem, it gets crazy. I understand that. So I am understanding of that, and I'll probably be a little more lenient on this week's assignments, the quizzes, and especially and the tests. So there is a test at the very end that you have to do. It's a little longer than the normal quizzes. So please be working towards getting your assignments done. Let me know if you have questions. Email me. Get in contact with me. Communication is the number one thing that will make you this successful for all of us. Some of you haven't done your assignments. It's time to get them done. It's time to do them. And it's time to take this serious because I've put grades in. You'll notice I put in the grade book earlier some grades for that. So just be mindful of that. Thank you all. Have a good rest of the day.